Cool. Thanks, Julia. Hey guys, my name's Hareesh. I'm an engineer at Amazon. I've been here for almost a year now. I'm also a trained interviewer there. I've also had the pleasure of interviewing with multiple different companies besides Amazon, including Google, Facebook, and a couple startups like Robinhood and Palantir, as well as a couple hedge funds such as Two Sigma. So hopefully, no matter which company you're trying to interview with, I can try to give you a little bit of insight based on my own experience. Um, Before we begin, can everybody see my screen? That's very important. Cool. All right, let's get started. Oh yeah, before that, disclaimer, these are my own opinions, learnings, beliefs, and in no way represent Amazon. Whatever I say doesn't represent my employer. All views are my own. I don't want to get a call from legal. And also, yeah, like Julia mentioned, we're recording today's session. So let's see. All right. So we'll give you a quick 10,000 foot overview on why we interview. So we're mainly just trying, it's not only just a test, we're trying to see how you'll perform on the job. And it's effectively a proxy for figuring out like, how are you going to, will you be able to succeed in this role? How will you perform in this role? Will you actually be able to move up to the next level? Primarily like what we look at Amazon, what we look at in Amazon specifically is, for new grads, can I expect to see you at the next level, which is SDE2, in 2 to 4 years. The main reason for that is SD1, which is our entry-level role, at which most new grads get, is typically, and like I said, entry-level role. And if you can't make it within 2 to 4 years, then there's no real future for you in the company. It's really harsh and it sucks, but sadly, that's the way things are. During these interviews, we typically split it into behavioral and technical portions. It's for the behavioral, we typically expect you to demonstrate certain leadership principles. For Amazon, for most other companies, they have their own criteria which they're trying to evaluate you on. Typically, it's pretty similar. We sort of bucket it into our own thing called leadership principles, but I'm pretty sure like Microsoft and Google have their own version of it. And what we typically expect to see in, at least for the behavioral interview and as well as maybe the technical interview, is we want to see you demonstrate certain principles. For new grads, we are expecting to see that you actually taking initiative when you are doing your projects, when you're, talking about your experiences. So like, I don't want to just see like, oh, you did this project. I want to see like, oh, I looked at this project, but I feel like there's a better way of doing it. And you created like a POC for it and actually, evaluated it and demonstrated like you've taken initiative to actually try to improve the project. The second thing is ability to deliver results, which is pretty straightforward. Regardless of any ambiguity or setbacks, you should be able to deliver your product with good quality on time. And typically this is going to involve like, talking to PMs, talking to UX, talking data engineering to make sure your product actually gets delivered. And then lastly, this is probably the most important one, which is learn and be curious. And that's basically what it sounds like. We're expecting you to be open to learning and taking criticism as well as any feedback and internalize it and try to improve yourself. And always like actively try to seek out new things and learn new things. All right, and now we'll move on to the two different types of interviews, which is typically phone screens versus on-sites. Both of these are very different, and we typically evaluate them and ask different questions because we're looking for two completely different things in both these interviews. I know for a lot of people, interviewers are kind of these mysterious gods which hold your employment in their hands, but keep in mind, like, when we decide to make a decision, regardless of whether it's for you or against you, we do have to justify it. We have to give concrete reasons, and if those reasons aren't valid, it will look bad against us during either our quarterly reviews or when our promotion's up. So we do have to. So when we do reject you, we probably have pretty good reasons to do so, and we do accept you. There are definitely good reasons to do so. And this last piece of advice isn't really necessary, but I would encourage you to try to be friendly because, it's an in-person interview. If we wanted to just test your data structure skills and your technical skills, we might as well just give you like a physical test. We're not only trying to evaluate your technical skills, we're also trying to evaluate your soft skills, such as your communication, your ability to, deal with ambiguity. Basically, like how, if we were to throw you in a job right now, how would you perform? That's basically why we're trying to do this. Do you guys usually give feedback to people if they're rejected after on-site interviews? No, we do not. It's pretty much against policy to do so. You can try asking your recruiters. They might occasionally try to be nice about it, but typically for the interviews themselves, it's strictly against policy for us to answer any questions about your performance. Yeah, and also quick disclaimer, everyone has a different interview style. For Amazon, we're required to ask you a leadership principle question, but I know at Google it's not necessarily required, and some people might ask one just to get you settled in. Some people might not. It just depends on the style. I'll try to be as general as possible so I can cover it from all angles, but just keep that in mind. So now let's move on to the next one. So how would you approach a behavioral question? So this is your chance to show off, right? Talk about some really cool project you worked on. It could be anything. Like, honestly, building a website is honestly pretty cool. We build websites a lot at Amazon. And it could even be something like some crazy ML algorithm. That'd also be pretty cool. But do keep in mind, like, I might not have the technical expertise to understand what you're saying. For example, I'm mainly interested in distributed systems. So when you start talking about ML, I might like start getting bored. And I mean, obviously I'll still take notes down, but do try to like tailor it towards what the interviewer does, just so they can engage with you more. And when you're talking about your projects, do like be very specific. Like when during interviews, what I see a lot is people start talking about their projects and they're very, very general about it. They're like, oh, I tried to improve traffic and I decided to implement a caching mechanism and I improved traffic. And that's great. But it gives me no context of why were you doing that? Like, what was the situation like? What sort of like specific actions did you individually take? And what was the metric you used to measure your success? So like, do explain what you're doing, why you're doing it, and why is it important? And explain what you, like the individual, did. Because when you use pronouns such as we built a caching mechanism or we built a website, that's great. But I don't really care about what your team did. I care about what you did and what you contributed to it. So try to use, when you're talking about things, talk about what you specifically did in these teams, and try to use pronouns like I instead of we. And lastly, like, tell me how you evaluated your success. Like, okay, you improved traffic, right? That's great. But when I'm writing down my feedback, like, I don't know how you evaluated that success. So I can't be like, oh, this guy improved traffic by 1 view, or did he improve it by 10,000 views? So when you're telling me about your success, be like, yeah, we improved traffic by 10%, which means we increased our traffic to our website by like 20,000 impressions, something like that. All right, let me step through an example. So the question we gave out was, give me an example of a time. Yeah, what Isaac was saying is very, very much correct. We have a lot of legal risks when we decide to give feedback to you. So we typically are very much prohibited from doing so. So yeah, the example is, give me an example of a time where you faced conflict while working on a team, and how did you handle it? So first off, when you take a look at this, I want you to explain the situation. So for example, my manager wanted me to use Java, but I wanted to use Golang for my intern project. And it was important because, using Java might cause a performance dip and it might result in more costs. So I believe that it would have been better to use Golang. What did I do to solve that? Well, I decided to benchmark Java and Golang against each other and see which one would perform better. And then I also decided to talk to engineers to address maintainability concerns. So what were the results? Well, I managed to convince my manager, because Golang is 40% faster than Java, and 4 out of 6 developers on my team were pretty much forced switching to Golang, whereas 2 showed no preference. And I also managed to make the cost around 70% of the Java version. To give a little bit of context, this is using serverless functions in AWS. So we get charged per runtime for how long each run lasts. Yeah, so what was good in this? Well, I explained the situation, which was I was trying to figure out a language for my intern project. Why is it important? Well, I need to figure out a language for my intern project, and choosing the wrong one could potentially result in increased costs, which we would very much not like. What did I do? Well, I explained exactly what I did. I benchmarked them, and I also talked to engineers to address both the performance and maintainability concerns. And I managed to give quantitative answers to what were my results. So like I showed Golang was faster. I also showed that most developers did agree with switching to Golang, and I also showed that I did decrease costs. So this would be a pretty good answer, and I would pretty much give this full marks. I don't know, maybe I'm being a bit biased because it's mine, but typically this is what I'm going to be looking for as an interviewer, for at least for a behavioral question. So that is it for behavioral questions. I'll move on to the technical portion now. So technical portions, typically you have two types. So you have on-sites versus phone screens. I did mention that on-sites and phone screens are very different. So on-sites are typically trying to answer the question of, will you, the candidate, be able to perform on the job? So if I threw you into the job right now, are you going to be able to succeed? Will you be able to get the next level? Are you to perform better than 50% of Amazon engineers? That's an internal requirement for us. Phone screens are slightly different. What we're typically, sorry for this question, do interviewers prefer you handling a technical problem or a non-technical? One's okay. Non-technical ones are fine. Like honestly, if you're a technical candidate, like an SDE or a suite, I would prefer it if you talked about technical problems. But there's no like hard and fast rule. Yeah, anyway, sorry. I was talking about phone screens versus on-sites. So phone screens are typically trying to answer the question of whether, like, can you, the candidate, get through the on-site loop? Like, will you be able to actually get through to the end and get the offer in hand? Quick note, for on-sites for interns are slightly different. We don't evaluate you based on whether you can get to the next level. We're evaluating you on based on whether you can get the full-time offer at the end of the internship. So yeah, that's the main difference between phone screens and on-sites. Phone screens are definitely a lot less rigorous. And if you fail a on-site, you won't necessarily fail a phone screen. Like, if, like, for example, if I feel that, oh, you might not, I'm going to evaluate you very differently based on whether it's an on-site or a phone screen. And for new grads and interns particularly, we heavily emphasize optimal code. So we really want to see that you can write the best code possible. Basically, like it should have the best runtime and best space complexity. This is very heavily emphasized, and if you don't, you are decreasing your chances. But that doesn't mean like you have to sit there and just try to figure it out on your own. We are allowed to give hints. So if you are stuck, do feel free to ask hints. I highly encourage it. In fact, because I'm trying to work through this problem with you. And another thing is, do keep in mind, like, don't just stare at the board for like 5 seconds and then be like, okay, I'm stuck. Give me a hint. I'd like to see like you at least try to attempt the question and you considered a couple of different solutions and you're like, hey, do you think I'm on the right track? Do you think like, what do you think I could do differently? That would encourage me more to help you. And I did mention earlier that I try to be friendly. If you are friendly, it might encourage me to help you a little bit more because I might be more inclined to root for you. So like I mentioned, we were expecting you to be good at data structures, but that's not the only thing we're evaluating. We're also evaluating your ability to problem solve. Most of the time, you're not going to be like implementing your own graph structure in an actual on the job, right? We're going to give you an ambiguous problem, something like, oh, I have this website that I want to build that's going to give me the SSNs for all of my employees, right? And I want to be able to do this extremely quickly. I want to have like less than 1 second response time for my website. Weird use case, but anyway, I want to see that you can actually like think through the problem and be able to explain alternative solutions and identify their trade-offs, right? Because what I see a lot of time during coding interviews is people just start immediately writing code. And that's like completely the opposite of what I'm expecting of you, because on the job, you're going to be, whenever you're implementing a new product or a new feature, you're going to be required to write a design doc. That design doc will be evaluated by your peers, by your senior engineer, by your manager. And then finally, once you get through all of that, then you can start writing your code. By writing your code first, you're putting the horse before the cart, I think, or cart before the horse. And it's sort of like the complete reverse of what you're doing. And it's a pretty big red flag. How important is time during technical interviews from Yamini Mother? So time is pretty important. I did forget to mention that during behavioral interview. Thank you for reminding me. But you should try to keep your answers concise. Please do keep in mind, like, you only have 30 to 45 minutes. So you do want to get enough time for all your technical interview questions. And sometimes I see like people spending all their time on this one question when I had like 2 or 3 follow-up questions I don't want to ask about it. Yeah, so I personally believe that you should keep track of your time and do like, don't start rambling or wasting too much time on a single portion. Also, for some reason, I see a couple of people thinking that you need to do design during new grad interviews. You don't. We do not expect any new grads or interns to do design interviews. Those are typically reserved for mid to senior level engineers. We also expect you to be able to test your code, which means like write test cases, actually evaluate it on the whiteboard, and have a pretty good understanding of the programming language of your choice, right? So for example, for Python, I could write a loop to iteratively reverse the string, but that's so pointless when there's already a function called reversed within it that does it for me in one line. And it just shows me that you don't have as strong of a grasp on the programming language. And it's not a huge deal, but it can count against. So if you're going to do something, please be sure to have a strong grasp on your programming language, and also please understand how the language works internally. In fact, one of the first questions that I was asked in my Amazon interview was, how do you implement hash maps? How are hash maps implemented internally in Java? So like, those are the questions that we will try to ask you, and you should be able to answer the questions for that. All right, hopefully that should, actually, that is pretty much it. So let's move on to the coding questions. All right, so coding question number 1 is just, given a string, check if it is a palindrome. So for example, if I have ABA, then it's a palindrome because it's forwards and backwards. It's the same. CDE is false because CDE is not equal to EDC. So when I take a look at this question, there are a couple of clarifying questions that I would like to ask. Does anyone have an idea of what some good clarifying questions could be? Just put it out in chat. Could be anything. No wrong answer. Yeah, so yeah, you guys are right. You guys are pretty good. So great job. Yeah, will the input be null or empty? Valid characters, do spaces count, capital, lowercase, symbols and numbers? Yeah, pretty much. That's exactly right. Yeah, so when the clarifying questions we want to ask are typically like, should we consider spaces? Do we care about special characters? Is it only alphanumeric? Yeah, if it's an empty string. Also, will the input actually, if it's only alphanumeric, will the input have spaces and special characters? All that sort of stuff are great questions, and they demonstrate that you can deal with ambiguity. So you're able to gather requirements to implement your feature, product, algorithm, whatever. Also, if you don't understand something in the question, do ask. Like, if you don't know what a palindrome is, please do ask me. There's no shame in that. It's better to ask me right now than, you know, to be fumbling 10 minutes later and then turn around and try to ask me, because you just wasted 10 minutes of your time and you have less time to implement everything. So try to, if you don't understand anything, there's no shame in asking. Please do. It's better to ask earlier than later. Is it okay to speak in the following form? I will consider empty strings a palindrome or not a palindrome. Well, No, because that's pretty ambiguous, right? Like, oh, should I consider empty strings as a palindrome or not a palindrome? Yeah, that's fine. What's your take on stating assumptions if you don't ask questions? What do you mean by that? Are you asking, like, as an interviewer, like, what assumptions should I state? No, I typically will not state any assumptions in an in-person interview. The main reason because being that I want you to ask the questions. That's actually like a key requirement that I'm really like looking for in you. I want you to be able to deal with ambiguity. So by asking those questions, gathering those requirements, it's showing me that like you can communicate, you know what questions to ask. Yeah, is it okay to assume X is a good is fine. That's a great way to phrase it. So yeah, I mean, typically interviewers are not going to state, they're not going to say assumptions too often. If they do expect you to ask follow-up questions to clarify it, because that's a pretty important part of the job. Anyway, now we have all of our requirements. So our input will only have alphanumeric characters, but our palindrome checker should be case insensitive. So that means our input will have uppercase and lowercase letters as well as numbers, but it will not have any special characters or spaces or anything like that. So based on just looking at this, we can think of a couple ideas. So can anyone think of one obvious idea? Any obvious idea? Could be the worst runtime ever. Yeah, so the one I was looking for was by AO. Yeah, I mean, check if the string is the same as its reverse. William, you got it. It's pretty much, we're trying to iterate from beginning it to the end towards the middle. I'm just trying to leave that towards the end so we can like have something to optimize. But yeah, so the first idea that all people come up with is they take a look at the string, they reverse it, and then they compare the two. That's fine. It's O of n for space and time, but it's not exactly the optimal solution. You don't have enough, you're using too much space. You can reduce the space. So yeah, you could do better. So instead of just reversing the string, we can just do what William suggested, which is move from both ends and move inward until we hit the middle and compare each character on the opposite side along the way. And what's the complexity for this? Well, it's O of n for time and O of 1s for space. Cool. It's probably not possible to do better because we can't really skip characters for a sublinear algorithm. So now let's take our algorithm and let's test it out. Let me see if I can open up an editor here. Let me reshare my screen. Here. Okay. Is hashing half one and half two also acceptable if it's even? No, because the entire point of this is like I'm trying to make you reduce your space. So like, I mean, like, what's the difference about between doing that and just, you know, like comparing doing the reversed one. Okay, guys, I'm gonna hold off on questions until the end just so we can get through this. All right, so anyway, like I said, we had our solution, which is basically go at both the ends and then move inward. So let's run our idea through an example. So let's say we have ABBA. Can everybody see this? Is this too tiny?
Yeah, that's a little small. If you could make it larger, that'd be great.
Okay. I apparently don't know how to zoom in sublime text. Okay, I'm just gonna move this to Google Docs. This will be easier. Give me a sec here. Sorry. Share screen, and here we are. All right, is that better? Can everyone see now?
Yeah, that's a lot better.
Cool. All right, so we have ABBA, and we decided, hey, we're going to try our idea where we're iterating from each end and moving inward. So we go from A and check the opposite side. It's an A. Then we check B, and then we move inward and check B and check the other B, and it's the same. So our thing works for this. Yes. And then let's say we try something else. Let's try AC, D, E, F. And we can try A, and then we check F, and it's not. So this is a no. So that's also true, based on our algorithm. Sorry. Now let's try something a bit bigger. So A, B, B, 1, 4 Bs, and then A. And we can see A and A are good, then B and B on the opposite side are good, B and B on the opposite side are good, and then B and then this B are good, and then we have these two in the middle, and we can see they don't match up. So that means this is not a palindrome. And based on our algorithm, this also works. Now, the one thing we didn't consider was that, we have to be case insensitive. So you have things like this where we have A in the beginning, which is capitalized. So you can just, if you're using something like Python, there's a function called .toLower. If you're not, you can always just subtract the ASCII value and get the lowercase value for it. And yeah, so obviously this is not like an exhaustive list of test cases. I highly suggest you come up with way more wacky edge cases, just so like you're absolutely sure your solution actually works. So assuming I did all of that, let's move on to actually coding it. So when you're coding it, before you start coding, be sure you tested everything, be sure you've thought of all of your solutions. And now when you're writing code, I don't expect your code to be perfect. After all, this is a whiteboard interview, but I do expect it to like be somewhat readable. And I also do expect it to, like if you have some syntactic issues, it's fine, but there shouldn't be like glaring issues which demonstrate, hey, you don't understand this language at all, right? So my language of choice is Python. You can obviously use any language of your choice. Typically, I think we recommend at Amazon, we recommend Python, Java, C, C++, or Ruby. So this is what mine would look like. And then while I is less than J, we want to check if the beginning of the string, I know how to type, and we're trying to check if it's equal to the end of the string. And if it's not. And if it's not, then we just return false. Otherwise, we just move our variables forward. And then if we succeed through all of these loops, then all we need to do is just return true. Now, as you're writing your code, I highly, highly, highly recommend that you actually step through with a couple examples. So like, I know you stepped through it here with your original idea, but just to test your code, I highly recommend you go through every single one of these, through each line, and like write out on the whiteboard how each variable changes. So to give you an example, let's try ABA. So our input, let's move this, input equals ABA, right? And our I is going to equal 0. And our length, our J, sorry, is going to equal 2. So is I less than J? Well, yeah, this is true. So then let's move over here. What's S of I? Well, S of I is going to equal A. And what's S of J? Well, S of J is going to also equal A. So this evaluates to false. And then we move up. And now after I plus equals 1, I is going to equal 1. Or, so, see, I caught a bug. And J minus equals 1. So J is going to equal 1. And then we go to the next loop and we can see that this evaluates to false. So we return true. So I highly recommend that you do this because as you just had seen live, you can catch bugs, and that's very, very beneficial. And also a lot of managers and engineers love it when you write test cases, because oftentimes when you're actually on the job, people just don't write unit tests, and it really sucks. So when you're actually showing initiative during the interview that you're able to write test cases, everybody's just going to love you. So highly recommend you do this. So yeah, based on this, we can see that our code works. Now, obviously, I'd also recommend stepping through a couple edge cases. So for example, maybe you tried out this, where we're trying to check out uppercase and lowercase, where we're trying to check case insensitivity. And we can see that's caught right here, where si.lower will catch that, because si is a, but s of I dot 2 dot lower is going to equal just regular a, which matches up with the other end. Anyway, that is the first question. So that's this is typically not too hard of an interview question. It's something you might see leading up to a more harder question, sort of like longest palindromic substring. And let me go back to this slide here. So that leads me into my second coding question, which is the longest palindromic substring, which is basically given a string S, find the longest palindromic substring in S. So basically, for example, in BABD, we have BAB, and in CBBD, we have BB. This is more representative of a question you're probably going to get during an actual interview. This is if you guys use Leetcode, this is like a medium level difficulty. I normally do not see many people giving you hard questions unless they really don't like you or are a very mean interviewer, or unless you're interviewing with a startup like Robinhood or a hedge fund like Citadel or Two Sigma. If you're trying to prep for hedge funds, highly recommend you go step through some dynamic programming problems. Basically, all my questions when I interviewed with them was just dynamic programming. So let's see how we're going to approach this. Let me open up the chat again here in a sec. Does anybody have any idea of any clarifying questions you want to ask for this? Somebody asked you to use Jane during an interview? That's weird. Sorry. Anyway, yeah. Anybody have any ideas for clarifying questions?
Can you show us the problem? Or like?
Oh, my bad. Sorry. Yeah. For this guy.
Thanks.
You can just convert the entire thing to the string to lowercase at the beginning. There's like either way works. I just did it this way because you're not going to use it as much space. Is a one string character a palindrome? Yeah. Oh, yeah, that's a clarifying question. Yeah, that's a good clarifying question. Same but for null. Yeah, that's a good question. Yeah, these are pretty much correct. Yeah, I'm basically the same things you're going to ask for multiple. Yeah, also this is a good one. Should be returned multiple same length substrings. Yeah, so. Can you write helper functions? Yes. Highly encourage you to write helper functions. I want your code to be readable. So if you take a look at this, actually, this guy, I would, for palindromic substring, if you're doing like, if you're gonna use this as part of your palindromic substring, where you're gonna check if the substring is a palindrome, I expect this to be a helper function. Was there any? Yeah, okay. Yeah, these are pretty much all pretty good questions. Great job. You guys don't even need me. So now that we've got pretty much all of our requirements, which is basically, it's the same requirements as our original is palindrome, all alphanumeric, you're not gonna have null input. Max length is gonna be like 1,000 characters, that sort of stuff. So now let's start thinking about some solutions. Oh, we're expected to return the entire longest substring. So if you notice in my example right here, I returned BAB, so I expect to return BAB. Yeah, so when you're talking about solutions for questions like these, I really, if you're stuck, I would highly recommend just like laying it out what you're thinking about. So like you might be thinking, oh, maybe I could use hash maps to improve runtime, so I don't have to constantly use my palindrome checker because that's O of n time, and just keep on like talking about stuff in that vein, which is relevant to the question. Don't be like, oh, for a string manipulation problem, I want to try to implement a graph. No, like try to be relevant to the question and try to lay out what you're thinking, because if I see that you're like veering off course, I'm gonna be more inclined and tempted to help you. So highly recommend, voice thinking out loud, and it also helps me get insight into how you're gonna solve the problem, and how, like your problem solving ability. So that just adds to the case of getting you hired. Anyway, let's move on to our first idea. So anybody have any ideas for brute force? Let's just go with brute force for now. How do we do this for brute force? Yeah, so generate all the substrings, check all the palindromes. Bonus points, do you know how many substrings there are? No, n squared. Yeah, that's correct, n squared. So yeah, so it's basically, you can basically calculate that by using the summation formula. Oh, so yeah, sure, I can explain the math behind it. So let's take ABA for example, right? So for ABA, what sort of substrings can we have? Well, for one letter substrings, we can have A, we can have B, we can have another B, and we can have an A. For two letter substrings, we can have AB and BA. For three letter substrings, we can have AB, B, or we can have BBA. And I think I'm missing one. Yeah, I am missing one. I'm gonna like this. So, and then for one sec, my computer's lagging a little bit here. Yeah, the substrings need to be contiguous. And then for four letter, you can have A, B, B, A. So you can see here that for one letter we have 4, then for two letter we have 3, then for three letter we have 2, and for four letter we have 1 substring, respectively. So you can see this is basically a summation based on the actual length of the what do you call it? The string. So for that, you can basically, the formula for calculating the total number of for calculating the summation is basically just n times n plus 1 divided by 2. And here you can see that this is going to simplify down to n squared plus n divided by 2. And, basically we can get rid of all of the constants, so, and the lower order terms. So it basically just becomes n squared. Does that make sense to everybody? Cool. All right. Yeah, so we can have n squared substrings, and we will have about n time to actually check if each substring is an actual palindrome. So that results in a runtime of about O of n cubed. And that's not great. It could be a lot better. And also, the nice thing is we're only using about O of 1 space. So yeah, we could do better. 1 sec here. Okay. Give me 1 second here, guys. My computer is running out of battery, so I will be back in 2 seconds. Really sorry.
Just to make one more quick announcement for all of you guys who are here or need to run out early, if you could fill out the feedback form, that would be amazing. Let's see, I am going to share the link once more. I'm putting it into the chat right now. Yeah, you can just go ahead and click that. And if you could fill that out for us, that we can make future events even better, please do that. That'd be super, super helpful. Thanks.
All right. Thanks, guys. Sorry about that. So yeah, well, yeah, we could do better. So how could we do better? Well, we could optimize two ways here. We could either avoid checking through all lengths of substrings, or we could try to improve our is palindrome checker. So let's take a look at an example here. Let's take a look at CDABADY. Now, in this case, let's take a look at, we know the longest palindromic substring is DABAD, right? Now, based on this, the way we're doing it currently is we're going to check each of these letters individually, and then we're going to move up to 2. So we check each pair of characters individually, and then finally we check the entire thing. And as you can probably notice, we're doing a lot of repeated work here, right? So, for example, we know B is a single character, so it's a substring of itself. That's a given. We consider that our base case. So when we check ABA, we don't really need to run the entire thing through our palindrome checker. We just need to check if the ends are the same. So we only need to check if A and A are the same. Now, we know that ABA is now a palindrome. So do we really need to run DABAD through the entire substring check, through the entire palindrome checker? We don't. We really just need to check the two ends, which is D and D, right? So this is sort of. It's basically just dynamic programming. We're basically using what we know previously to on previous subproblems to build on top of each other, and basically reduce our is palindrome checker down to constant time. Yeah. So yeah, basically, yeah. So start from the middle and go outwards. Yeah. So yeah. So the way we could do this is basically we can set up a 2D Boolean array, which looks something like this. So like 1, 2, 3, 4, and then 1, 2, 3, 4. And then we know for all of the one letter characters, they're all going to be true because they're palindromes of themselves. So we can just say this is 1, this is 1, this is also 1, and this is also 1. And then let's say we're going to check 1, 2. So we can use our previous substring to check if 1, 2 is a palindrome. Then we can do the same for 1, 3, 2, 3, 3, 4, all that sort of stuff. And then based on that, we can finally return like our longest substring. So this is great because now we've basically reduced our runtime down to O of n squared, right? Because we've basically we've used our the previous palindromes to basically discard the need for our is palindrome checker, which is amazing, right? So the only unfortunate part is we're still using O of n squared space, right? Because we have this 2D array right here. Now, could we reduce this? Yeah, we probably can. And that leads me back to what I mentioned before. We could either reduce the number of substrings we're checking, or we could just reduce the amount of time the is palindrome checker is taking. So in this case, we're going to try to reduce the number of substrings we're checking. So instead of checking every single substring, we can take into account the fact of something that was given in the question, which is that we're looking for a palindrome. Now, take a look at, for example, this palindrome right here, right? And you can see that if I split this down the middle, they're basically the same on both halves. It's something that I think someone else mentioned before, William mentioned before, where he's basically said, can I take the hashes of both sides? So yeah, it's because both sides are equal. Something I'm pretty sure a lot of you noticed by now. So based on this, what we really need to check is, we don't really need to check through all the substrings. We just need to go from, figure out all the centers and then expand out from there and check if that is a, and then basically go until we hit two characters that don't match up. So to give you an idea, it's basically what I demonstrated before. We start at B. So we have an I-J pointer, start at B, and then we go to A on both sides, and then we go to D on both sides, and then we hit C and Y, and we know that both of them are not equal. So we say that our current longest substring is DABAD. Now, this one basically depends on you realizing the fact that a palindrome is basically a mirror image across the center, and figuring out a solution to utilize centers instead of the actual substrings. So yeah, it's like a pretty good way of figuring out your problem solving skills there. So how does this reduce the number of strings we're checking? Well, we still have our palindrome checker, albeit it's a bit different. Before we were moving inward towards, that's the wrong arrow, towards the center. In this case, we're doing the opposite. We're going to go from the center outward. Right. And this basically means that we have, instead of having n squared strings to check, we only have to loop through n times. Technically, 2 of n minus 1 and 2 of n minus 1 times, because we have n characters, and then we also have to consider the even case where we have centers in between these letters. So it's like between like in this case we have the center in between B and B. So that basically reduces our runtime down to O of n squared, which is the same as our previous result, but we dropped our space down to O of 1. Now, can we do can we do better? Yeah, we probably can do better. In fact, there's an algorithm called Maneker's algorithm, which allows you to do this in linear time, but no one's going to expect you to memorize that. If you do, great job. You're definitely going to pass that interview, but it is not expected, and don't spend your time memorizing algorithms you don't really need to. Get better problem solving. So now that we've come up with a solution, let's just loop through a couple. So Vanessa asked, what about when the middle section isn't the longest palindrome, like the longest palindrome actually exists closer to the front of the string? Yeah, so sorry, I didn't explain this correctly. So basically what we're doing is we consider each letter to be our center. So let's take this, let's actually just take this string, for example, and let's mutate this a little bit. So CDA, CDCA, BB, RF. So you can see like here, the palindromes in the beginning, it's CDC. So first what we do is we check C, and then after that, we move outwards from C. So we'd go this way, and then we would go this way. And we can see there's nothing on this side of C, but there is a D on this side. So we just say, you know what, this isn't gonna, we're just gonna ignore this, let's move on to the next one. So now we don't move on to D, instead we move on to the middle right here, between C and D. And we check if C and D are equal. They're not, meaning this is not a two-string palindrome, so we can move on. And then we move on to D, and then we move this way and this way. And C and C are equal, so that means we move here and to here. And we can see A does not match up with, there's nothing on the other side of C. So based on that, we know our palindrome is CDC. Then we move on to C, do the same thing, keep repeating until the end, and you can see like basically CDC is the only palindrome in this string, and it's the only longest one. So that's why algorithm works. Does that sort of make sense? Sorry if I'm not explaining this properly. Cool. Now let's test. Now yeah, obviously, we're pretty much out of time right now, so I'm going to skip the part where I test this across a couple examples and just go straight to coding it. So how I would expect you to code it is I do want you to write a helper function like Julia mentioned. So write a actual function, let's call it checker, for example, and let's say S, L, and R, that's 1. And here I want you to loop through greater than 0, and then R is less. So another thing to note is you don't have to explain your code when you're writing it down. If you want to code silently, that's completely fine. When you're thinking about solutions or when you're stuck, I do want you to talk about it because I can't read your mind. I'm sorry. I try. But yeah, I really only expect you to talk when you're thinking about a solution or when you're stuck or when you're just not coding. If you're coding, you can just be quiet and code if you'd like, or you can explain your code as you're writing it. And that, and then basically what we do is we just return the substring. And that's our checker. So then all we do is longest palindrome, and then we have our string, and then we have a result. Yep. Result was this, and then we just iterate through our string, the length of our string, and for each one we just do this. And so this is, so you can see like this one right here is for the odd case, and this one that I'm writing right now is, no, I do not expect to memorize algorithms. Like if you are, just, don't. It's like, we're not really testing for your memorization ability, we're testing for your problem solving ability. So if you're memorizing stuff, even if you can pass the interview, it's going to be difficult for you during the actual job. So don't try to memorize algorithms. It's a bad habit. And then all we need to do is this and key equals length. So this one right, my bad. So this one right here, it's basically just checking the max size between the odd, the even, and the current result, the current max palindrome. Sure, yeah, I can show the slides later. And yeah, then all we really need to do is return the result. Yeah. William's correct. Yeah. So, for example, like there's some problems that require you to use like union find, and that's the optimal solution. I don't expect you to know that, but if you mention it, it's like it's good because it's showing me, hey, you have a pretty good grasp of data structures. Yeah, we're pretty much out of time, so I can't really step through this with an example, but I would expect you to also, write down a couple test cases, step through this like how I did for the previous question, make sure you catch any bugs you find. Yeah, so typically I don't expect, like I really want to emphasize, I don't expect to memorize these fancy algorithms like Manicure's algorithm. It's unrealistic to expect you to come up with something like that. I think there's like a bunch of people who have a particular hatred for when people do that. So another thing to note is some interviewers like to ask these like puzzler questions where you basically have to come to some transcendent realization to solve the problem. Otherwise, you're screwed. Thankfully, these seem to be sort of dipping in popularity. And luckily, I haven't really encountered any of those in my interviews. So yeah, those problems suck. Don't optimize for those problems. Optimize for problems like these. Problems like these, right? Anyway, yeah, that's pretty much it, guys. Hopefully you learned something. If not, hopefully you had a couple laughs at the comics and my awkwardness.
Awesome. Thank you so much, Hareesh. This was amazing. I'm going to end the recording.